Hi everybody, we are here today with Howard Buffi and we are going to be talking about the hole in the ground, as I've been calling it. There's some work being done down at the water treatment plant, and the extent of my knowledge about this is that there is a hole, there's a fence, and something is happening. So
yes,
let us know.
And we've had lots of curiosity about it. So the water plant, we're going a small expansion. So what the expansion is a reservoir. So the reservoir is going to be a separate building from the water plant, and as people have noticed that have driven by, it's quite a deep hole. It's going to be a fairly large reservoir. This reservoir is going to hold 2.8 million liters.
I have no concept of how much water that is.
Okay, so I did a little conversion here.
Okay.
So that's 622,000 gallons, if that helps you anything.
A little bit. How many swimming pools is that?
I'd have to do that math. So basically, if you'd look at it, if you would squish in about 4 houses into an area,
yeah,
that's kind of the size it would be for
yeah.
volume-wise. So right now, so that's going to be an additional 2.8 million. So
yeah.
Right now, we have 2 reservoirs under the existing plant. One is 0.587 million liters. And the other one was built in 1962. It was 0.670 million liters. So underneath the water plant, we have almost 1.3 million liters.
Right.
So then we'll add that 2.8 million what we're building on. Yeah. And our tower also has 2.2 million liters. And I get this reaction normally is like, what do you need all this water for? Okay, so when you add that entire allotment up, if everything was 100% full,
yep.
You would have 6.3 million liters.
Okay.
Which sounds like an awful lot of water. Our plant in August, we ran 3.3 million per day.
Per day.
Per day. So now the concept of building a bigger reservoir is, it's like having a bigger tank on your car, right?
Yeah.
You can go farther. But one other thing we look forward, or not, we don't look forward to it, but if we break down, okay, so we need time to repair stuff.
Right.
So when you look at that 3.3 on the average, but that's also taken in the weekends, which are sometimes very minimal, right? Mm-hmm. So yeah. During the week, we're probably in very close to the 4 million.
Yeah.
So if our entire reservoir right full is 6.3, that doesn't help you much if you're half, when you break down, that doesn't leave you any cushion, right? And we have jobs we have to do. We swab the main lines and stuff like that. And when we swab those lines, we do them once a year. And that we actually shut the plant off for 17 hours. That's getting next to impossible right now. So that's, again, that extra reservoir is going to...
tank runs dry at that point.
Exactly.
So
and we can't, and our tank can't run dry, right? So that's why this expansion is. It's just going to make life easier for everybody. Yeah. You're not on pins and needles that you're going to make it through to the next day. So.
Which is probably a problem that most people had never thought about until you just brought it up. Yeah. But so what is the service area of the town water services?
Okay, so the town not only does the town area itself, it does High Life. We also go out north into Rosedale, and we go kind of southeast into Langford, and we also go west into Langford. So we've covered a substantial area, and when I say into Langford, that goes all the way to Franklin and quite a ways out. I know when I first started once, I was talking to a fellow, and he was telling me his water problems. I was at home in the middle of my field feeding the cows, and this guy phones me up, because when you're on call, right? Yep. And he phones me up, and I says, well, that can't be our water, because I just started, I didn't know. And it was, and he was like 20 miles away from here, and you're going,
So we have lines out
a lot
everywhere.
of lines going out, yeah. So
I don't think I realized that, because when we talk about, building new subdivisions in Neepawa and stuff, things we're talking about are water and sewage. Do they have service in that area?
Yeah, our water goes a long ways. Our sewage doesn't. That's
a different thing entirely.
That's a different thing. Yeah.
The in and out. That's
yeah. So hopefully this will alleviate some of the issues we have. And it not only does for, let's say you have breakdowns, which you lose time.
Right.
We all have the water flushing from the well sites, which 17-hour day. We have we have an RO system. So our water treatment plant used to be a clarifier system. It's an RO system now. So most people know about reverse osmosis, at least a slight concept about it. So the system we use, the way it's designed, actually works quite well. So our raw water that comes in, we actually retain or make about 85% we keep. So a lot of RO systems, you know, for every gallon you go through, you lose like 3/4 of that.
Yeah.
We're actually keeping more than 3/4. So it's good that way. But yeah, so on that RO system, when you have a little RO system at home, your cartridge gets dirty, you throw it out.
Right.
And well, in the big RO system, I don't want to spend $300,000 or $400,000 to throw these cartridges away every 6 months.
Yeah.
So we have to do cleaning cycles, and cleaning cycles is basically just like doing your dishes, except it uses a different type of cleaner, and you literally flush it through the membranes over and over and again, and it slowly dissolves the problems that are in there to wash that out. So when you're doing that, that also, you have no production. So again, this reservoir is going to help with that. So we can do that properly without worrying about running out of water all the time. And we do have some of our consumers like High Life, which has been expanding. I've been here, in March I'll have been here 12 years. And they've been expanding ever since I came till now. So water production plus more housing in town, and there's just more and more need. So
and I have to imagine that a lot of the water is being for industrial use rather than just home use, or do you have any idea what the balance
High Life
is
is
there?
very close to 50% of our water.
Okay.
We do have some other businesses that take water, but nothing to that extent.
Right.
So the other almost 50% is, and when I say home, I mean it could be somebody in the country watering their cows, right?
Right.
But it's going to their
still
house.
Personal use. Yeah.
So and we do have people that load for spraying and stuff like that. So there's a lot of, it's not just drinking. And this summer, of course, grass.
Yes.
Everybody wanted green grass, you know, and
I let mine go.
Yeah.
I'll drink the water.
A lot of people did, and it from my point of view, it's hard to look at that water watering your grass when you know how much effort it's gone in to make that water safe to drink.
Yeah.
Something presentable to drink, safe to drink, and then of course we add our fluoride on top of that, which helps. Other than the wet, none of that helps the grass.
No,
you know?
no, that is helping us, not our,
so it's a little hard for me to watch that because I kind of go, you're wasting water, but it's something that has to happen. So.
Yeah. So without getting into the technical detail that I wouldn't understand, what is the process? Like, where does our water come from, and how does it come into my tap? What is the process that it goes through?
Okay. So we have 5 wells at 3 separate well sites.
Okay.
So in those 5 wells, we have to apply for licenses. So the license will come from the government, and they figure out how much that ground will produce without causing problems, is basically what it boils down to. So once you got that license, our highest license is 45 liters a second from a well site, and our lowest is 30.
Okay.
So when I say a site, that site might have 2 wells, right? So normally we'll run one or the other or both at half flow.
Okay.
And that's what we've started to doing now, is running them 2 at half flow. It's a little easier on the ground formation.
Yeah.
So you don't want to plug it up down there either, because that's tough to undo.
And you also want the redundancy in there. If one of them is not working, you have.
So we have 2 well sites at what they call, local people will know it, it's called Hummerston. So that's around where the community pasture is.
Okay, yeah.
So from the water plant, if you go south down the number 5 and then a little bit east, it's almost 12 miles away from here. The Oberon well site is, again, south down the number 5, but then it's just a tiny bit west. Again, about 12 miles away.
Yeah.
So they're both 12 miles away, but the well sites themselves are 12 miles apart. So we almost got a triangle, right? So all that water, the Hummerston well site comes in a 10-inch line. The Oberon one comes in a 12-inch line. It comes to a trunk at the Highway 5, and then it goes to a 14-inch line, and that comes all the way down the highway and across from Hillcrest straight to our water plant.
Okay, these are buried pipes, or
buried pipes, yeah. So that's just getting it here. And of course, we have signals going back and forth to tell it when to run, how fast to run, and all that. And that's all done through radio. And so that's how that part works. So then we get the water to the plant. So the water comes to the plant. We take about 60% of the water that comes in. Well, let me back up a little bit. We'll take all the water, we go through a filter.
Right.
This filter takes out iron, manganese, and arsenic. So to a manageable level.
Right.
I won't say out. It's
drinkable.
Well below drinking water guidelines.
Okay.
So once we've got that, we take 40% of that water, and we will take that. Now, in order to go through the filter, we have to add chlorine to it, which oxidizes the metals out of it. So
Okay.
in simple terms, it just makes it separate from the water so the filter can keep that. So when we've done that, so we've reduced the iron, manganese, and arsenic. So that 40% of the water already has chlorine in. It'll go around and it'll head for the reservoir. The 60% goes around, it gets repumped, and it gets pumped through the ROs. So that the ROs will take that 60% of water, they'll lose about 5% of that water, and then they'll turn around and dump it with the other water, which we call bypass water. So they come back together. They get rechlorinated, they get chemicals added. I won't say too much about the chemicals. Some people love them, some people hate them. But chlorine is a big one. We add fluoride and stuff like that. And other chemicals are for the RO to work. So when those two waters come back together, and the reason we do that is because if you run, like if you're in your house and you bring water through a little RO system and you drink it and you go, oh man, that tastes so good. You can't run that water through a municipal, like our infrastructure in town is cast and all kinds of different, you know. So an RO water itself typically is going to be down in the neighborhood of 6, just under 6 or just over 6 pH. So it's a very aggressive water.
Yeah.
So if we were to put that in the town pipes, it reacts with the pipes, it eats everything off the pipes, and then it starts eating the pipes.
Okay.
And then all of a sudden you get real nasty water because you're literally drinking your pipes, right? Because
corroding the pipes and drinking what's coming through.
It's actually eating it off. It's like an acid, right?
Yeah.
So we blend the water, and the reason we do that, we have the aggressive water from the RO, which is totally pure, tastes great, everything's fantastic, but if we put it in the pipes, we'd have a disaster. So we blend the other water with it. Between the two of them, we get a fairly good water. Then we add, I guess for layman's term, we'll call it a caustic. So that's the opposite end of the spectrum of what an acid is, right?
So that's the base.
Yeah. So we add.
I remember high school chemistry to that point. Okay.
So we add a little bit of a strong base to bring the pH up in the water, and then when it goes out into the town system, what we want to do is get that water so what we call is stable. So there's no reaction with any of the plumbing or anything like that. Some people still have lead lines in town. Well, if you have a reaction with lead and you take that lead with you, you're drinking it, right?
Yeah.
So we want to get that zero reaction. We don't want to go too far the other way because you can actually get scaling, which will go the other way, right? So we just want that zero if we can get it. And that's what we're always trying to achieve. So if we get that zero reaction water and it comes into the town system and you drink it, and it tastes pretty much the same as what's at the water plant. So that's the big balancing act. The water can start out safe, but if you have a reaction in your pipes, then that's all gone, right?
Right. Okay.
And a lot of people ask me the question, well, it doesn't matter anyhow. I bring it into my house and I run it through a softener. You've totally destabilized the water again.
Yeah.
And if you wonder why anybody with an older home has got galvanized plumbing or even copper plumbing, and all of a sudden they go, oh, we got a leak here. Oh, we got a leak there. Because you've made that water aggressive again by altering its chemistry. And,
you've changed the pH on your water.
I don't know if that's totally answered your
No, actually it does.
There.
So I can sort of envision where it comes from, how it gets there.
Yeah.
So say we were to drain the reservoirs. How long does it take us to fill that at the rate that you generally put it in?
Well, if I could shut the town off.
This is a purely theoretical exercise. All right.
Well, I'd have to sit and do some math. But right now, we have 2 RO systems in the basement.
Yeah.
They're each 3-stage systems, which mean the water goes through one stage and then through another stage and then through another stage. We're always trying to recapture so we get a higher percentage of kept water. So So if we use one RO system and the water that comes with the bypass of one RO system, we're bringing in 42 liters a second.
Okay.
So if we use both RO systems and we're running at full capacity, we're bringing in 84 liters a second.
Okay.
So that by the time you have your percentage loss in that, you'd be just under 80 liters a second. So 80 liters a second to make millions of liters takes a long time.
Yes.
It takes a long time, yeah. And our system right now, we're running 8 to 10 hours of full flow. And then we get the rest of the day, and I mean the rest of the 24 hours. It doesn't shut off for 10 hours or something. It runs the rest of the day just in single train at that 42 liters a second. So that's, the town is getting substantial capacity of water. And we're slowly, always continuously changing and trying to make things more efficient and doing stuff to increase what we can do or at least sustain a higher volume,
as the demand doesn't go down, I imagine it always goes up.
Right, and especially as the town grows.
Yeah.
As the town grows, the demand keeps going up, and that's the same reason why we're getting the wastewater plant, because the government said, well, you're creating so much now, you have to do another next step, right? And
yeah.
So it just one thing leads to another,
but we continue to grow, and that's not a bad thing, I guess. So
it isn't.
So what is our timeline for this project? When do we expect completion on this?
Well,
roughly.
There's a timeline what's projected, and then there's a timeline what I project.
Realistically.
I'm hoping we're going to be done by spring.
Okay.
So that will, because there's a lot of, because holding that much volume, like if you have a glass of water, you only need a wall of this as big as a glass, right? 1/16 of an inch, it'll hold it. Once you get millions and millions of liters, there's so much force.
The weight of that alone.
Yeah, there's substantial, the cement walls are substantially thick, lots of rebar, heavy rebar, and it looks like they're trying to build a fishing net. There's so much rebar in the cement, but yeah, you need the strength in order to hold the water, and also to hold any shifting. If the ground shifts or anything like this, it has to be strong enough, right?
Right, of course.
So with this also, and one thing I didn't mention is with the new reservoir, there's going to be a small building, well, probably a normal sized building, but it'll look small on top of the reservoir. That's going to have 5 distribution pumps in. So that is, and normally they're just going to alternate. This one will run, that one will run, or 2 will run, or these 2 will run, or whatever. But it also gives us a really good handle on fire, like through hydrants and stuff, how much water we have to put out if there's a fire. Like it brings mind back to when we had the home hardware fire.
Of course, yeah.
And the water demand we had then, and we had 2 pumps that could produce the water at that time. And we did have what they called a fire pump at the time, but nothing was really designed so you could run them all at once. So it was very hard to keep up to that volume.
Right.
And then towards the end, it was getting hard to keep any water in the reservoir, right? So hopefully this will give us a lot more, be able to take a shock like that and recover
You've
without.
got that backup.
Yeah. Just take that panic feature away.
So for the average person, will they notice any difference once this happens?
Shouldn't really notice anything. Like I was talking about the pump system and how we could pump water faster, but I don't know if, well, probably most of the people realize that our water actually comes from the tower. So when our pumps kick in, all we're doing is pushing water to the tower, and the pressure is coming from the height of the tower, and that's where everybody gets their water. So if anybody's listening and has recently called in and said the pressure's too low, I should turn another pump on, I can't do that. It's total gravity is what feeds you your pressure, and it is what it is. Yeah.
We don't have control over gravity.
No.
Yet.
No. We can just go higher.
Yeah.
If we could raise that tower higher in the air, we'd have more pressure, right? But that's not going to happen. So, but yeah, that's more and more technical stuff also will happen with this. Programming is a big thing now in all the water plants. I know when I started, you basically walked in and turned a couple of switches on and away everything went.
Yeah.
Now everything's totally computerized. You have a programmer come out and he adds little features onto your program, much like any other program, except these are hundreds of pages long of just gibberish.
Yeah.
And so anyhow, so this will also add another loop into that. They'll have to make this fit into our programming.
Right.
It's another step, another thing that has to happen. And also when you have more reservoirs, you always have to rely on, well, if this one's not working or we're cleaning this one, how can we make water and put it there instead of here? And so there's more plumbing that way. So you
a lot
can
of logistics.
Yeah, you got to rotate everything. It's just like a road. If you had a road and you have to close this one, how's the traffic going to make it around, right? So that's kind of what we're doing with the water, so that, you know, if you have to clean a reservoir, well, we have to do a different thing. Well, if this pump breaks, we have to do a different thing.
We have to reroute this way or that way,
Yeah.
or the other thing. So. Are there a lot of people working down there, or is it a little sort of a low?
I have 2 employees right now as operators, and then there's myself as a supervisor. It's kind of an ongoing change there. Some people don't want to get into that type of work. I guess it's somewhat the responsibility, you know, because
it is a big responsibility.
Like most jobs, I did that wrong. Oh well.
Fix it tomorrow.
There's no oh well in our job.
Yeah.
You have to stay focused. You have to do it right, because it's like baking a cake. You either end up with a cake or a brick, right?
Yep.
We can't have a brick.
Thank you for all of our cakes.
We're trying hard.
Is there anything else that you'd like people to know about the system or about what's going on?
Not so much about the system, but if anybody is curious and they've noticed, I've done a few videos prior to this, and we did change from the lake, so we're not on the lake anymore, we're on the wells. So about 9 years ago, you'd have noticed a substantial water change in your tap. Our chlorine, we're feeding not even a tenth of what we used to.
Wow.
Because lake water through a clarifier was really hard to make drinkable.
Right.
And this water, a lot of people that live out in that area says, well, why do you treat it? I drink it the way it is. Well, you can, but it is high in iron, high in manganese, and there's a bit of arsenic in there. And they're starting with some of these, well, the guidelines, they have recommendations. Some things are just recommended, and some things are licensed that you have to get to. And lead is the new and upcoming one, and manganese is the other one.
Okay.
So through our filter, we can take the manganese down to a good enough level the way it is. Plus then the 60% that goes through the RO even drops it even more. So our manganese is really low. And so they're finding that to be now a bit of a health concern. So we're already on top of that one. So
okay.
Yeah. So
I'm
if
sure
you
it's regulated fairly closely.
Yeah. The biggest thing right now, and it's always been, is the chlorine levels and your bacterial results. I don't know if people have noticed, we're going into businesses around town every 2 weeks, and we send samples away, and a lot of people go, what are you doing? What are you doing in there? What are you taking the toolbox in the bathroom for? But so we're mandated to send samples away, and those samples have to come back with 0 bacteria. Not low bacteria, not less than 1, 0.
Okay.
So if it doesn't meet the 0 guideline, then you'll hear, oh, this town is on a boil water, or that town's in a boil water. And we've had a few minor ones, but none of ours have been from that. Any boil water advisories we've had, if you repair a line and the pressure drops to 0, you have to call that a boil water. And when they get it repaired, then you have to sample that water a few times, and it has to come back good every time. And then once that's came back and everything's good, then they let you,
then
you're good again. But 99.999% of the time the water was good anyhow, but you have to go through that protocol.
Right, just safety protocols basically,
Yeah, so just to make sure.
Just to make, well, that's great. Thank you so much for sitting down with me today. I think we're going to go down now to the site and sort of take a look at what's going on and get a little sneak peek in there. So we will see you all soon. So what did you say that cement pack was called?
They called it a mud pack.
Mud pack, yeah. That is some extensive rebar.
Yeah, no, I don't think they're done yet. They're just...
Yeah. When you said fishing net, you were not kidding.
Yeah.
And so this entire area here is going to be the...
all the cement area. Yeah.
All the cement area. And then how deep does it...
It'll be in the neighborhood of about 15 feet or something, yeah.
Okay.
So that cement's where it is now. You can see how high it is on the side.
Yep.
So that's going to come about 3 to 4 feet above ground level.
Okay.
And then there'll be a building on top of that in this corner.
Right. So we're just right at the base here is where it's all happening right now.
Right.
That is something.
They mess around and use a chalk line to put rebar down, eh?
I want to go home and do some math now and figure out what the weight of that water would be.
Yeah.
Because that is some tremendous, I mean, a bucket of water is heavy.
Yeah.
Let alone, you know, millions of gallons or millions of liters of water.
2.8 million liters.
Yeah.
Yep, and a lot of weight. And plus, the ceiling on this is going to be cement as well, right? And this is also divided into cells. I think there's 4 cells.
Okay.
So there'd be dividing walls, plus the ceiling, and plus the building on top.
So if anything happens to any one of those, it doesn't necessarily impact all of them, or is that?
Well, exactly. So
Yeah.
yeah.